moon of Uranus, and some others were discovered. And so scientists had a somewhat accurate estimate of the mass of this new planet, and soon realized that it didn't seem to be moving in its orbit as they would have predicted based on this mass. And soon scientists started thinking, perhaps there's another body out there whose gravity is tugging on Uranus, causing it to wobble in its orbit, inconsistent with what they expected. So for several years, different mathematicians worked on this. And in the mid-1800s, a French astronomer, Urbain Le Verrier, and then an English astronomer or a mathematician, John Couch Adams, working independently, they both came up with a solution at about the same time. And in 1846, over at the Berlin Observatory, Johann Galle, based on these predictions, looked in the sky, and within about 45 minutes of where they said to look, he discovered Neptune. So Neptune was really, it was predicted mathematically and very accurately, and that's discovered in 1846. So as astronomers studied Neptune, they realized, this doesn't seem to account for all those perturbations. Perhaps there might be another planet out there. And there are different astronomers who've worked on this. William Pickering at Harvard predicted several different planets that might be out there. But probably most famously, and the one that directly led to the discovery of Pluto, started with this guy, Percival Lowell. And Percival Lowell is a really interesting character in astronomical history. You see his picture, and sometimes there's a little chuckling because, oh, he's the guy that came up with this theory of life on Mars. And that's probably what he's most remembered for. This is one of his maps he drew of Mars, of the network of canals made, he believed, by a population because Mars was dying. It was drying out, so they built a series of canals from the polar ice caps to the rest of the planet. And of course, we know today that that's not true. But what's interesting about Lowell is he put so many things in place, whether he was what we would consider right or wrong, he put so many things in place that led to major discoveries or major research, such as the first evidence of the expanding universe, as well as a new planet. So he, as he was studying Mars and really looking for that proof of intelligent life there, he started studying the other planets and trying to understand how they were formed. And he coined the term planetology. If we think about the timing of this is the late 1890s. Charles Darwin had come up with the theory of evolution in 1859, and that was biological. But gosh, every discipline, it seems like, used Darwin's evolution to explain things. There was economy, there was space. Percival Lowell came up with this idea that planets evolve in time and space. So when they're formed, they're these gas giants like Saturn, Uranus, Neptune, Jupiter. And then over time, as they mature, they lose some of that gas, they solidify, and they're kind of in moderate age, like Earth, Mercury, and Venus. And as they get older, they lose all the atmosphere, they dry out, they become a dead planet, Mercury. So Percival Lowell thought, well, Mars is in the right stage of evolution, the same as Earth. It's solid, it must have life there. That was his thinking on why there was life out there. And then to him, the canals were proof, even though we know the canals don't exist. But as he's studying the planets, he realized that maybe there is another planet out there, like some other astronomers. His first ideas were that comets seem to be grouping in the outer solar system, and so maybe that was evidence that there's a planet out there. He soon gave up on that idea, and then went back to the Uranus and Neptune, that they didn't seem to be accounting. Their mass didn't seem to account for the irregular movements. So he first predicted, in 1903, he gave a series of lectures at MIT where he talked about this idea. And then in 1905, he published a book where he said, I think there's a planet out there. And it was sort of a haphazard search. Initially, he wasn't spending all his time on it. He started by using the 24-inch Clark refractor at Lowell Observatory. That's the image on the left. And so starting in 1905 and off and on for the next 10, 11 years, he kept toying with it, mostly telescopically initially, using different telescopes. The 24-inch refractor was much too large. His idea was to look for parallax. If this planet was out there and you could see it easily through a telescope, somebody would have already seen it, he figured. So he would search for it photographically, take pictures in the sky, wait a few days, take pictures again, and then analyze the pictures and look for any little dots that change position. Out of a plate that was various sizes, 8 by 10 and smaller, he'd have a couple 100,000 dots to look at. And initially he did it very inefficiently. He would superimpose the plates on each other and then hold them up to the light and then look and see if any of those dots didn't overlap. But it was his first stab. So that's how he did the project. He tried different telescopes. When I say he, it was his staff that was doing most of the observing. One of the telescopes, this one on the right, that was a 9-inch Brashear telescope. And there's a fellow named Thomas Gill using it there. And in 1915, Gill imaged several areas of the sky, and the images weren't very good, and they never really got analyzed. After Pluto was discovered in 1930, the scientists went back on old plates and realized that they, in fact, had captured Pluto on some of these old plates, but never realized it. They were so tiny, they were just tiny dots. You can see how they would have missed it. But this is the telescope, the first telescope to image Pluto at Lowell Observatory, at least, even though they didn't know it for years. So as time went on, Lowell spent more and more of his time looking for this planet and got more, I guess, scientifically rigorous about it. He realized that superimposing plates and holding up to light wasn't very efficient. And so in 1912, he purchased this blink comparator made by Zeiss. And this allowed him to more efficiently analyze plates, to put one on each side. And then in the middle is a microscope eyepiece. And there's a mirror inside here that flips back and forth. You see a small section of this plate and then the same small section over here. And it'll blink back and forth, looking at the same field of view, looking for a needle in a haystack, a little dot that might change position. And so that was the search for a few years. And then he bumped it up by hiring computers. And this is not a great picture, but it's one of the few we have of Elizabeth Williams, one of the unsung heroes, I think, of astronomy, and a fascinating person. She was one of the first female graduates at MIT. I'd like to see a biography done about her at some point. She was brilliant. Percival Lowell knew about her in his astronomy circles in Boston, so hired her, and she soon became the chief computer, the main computer. He had several of them. She led this effort. And I think if you get a chance to look up Elizabeth Williams, there's not much information, but she worked on this project, came up with some solutions for Lowell, and then eventually, after Percival Lowell died, she continued at the observatory, and she ended up marrying one of the astronomers who studied Mars. The next day, Percival Lowell's widow fired her because she didn't think it was appropriate to have a married woman working. And that's just a sign of the times. But I think it's interesting to look back and see how women have really come forth in a male-dominated field, led by people like this. So she ended up moving to Jamaica with her husband, where they did astronomy for years. So Elizabeth Williams led these mathematical studies. And in 1915, Percival Lowell, based on these calculations by Williams and the team, while one team is telescopically looking in the sky, another team is mathematically figuring out where this thing should be based on the apparent irregular motions of Uranus and Neptune. In 1915, Lowell published this memoir on a trans-Neptunian planet. And it seemed like he had a solution. 2 different places in the sky where this new planet theoretically could be. And he probably would have searching those areas more closely after this. But just a few months later, he died. And that was the end of the project. This is his mausoleum. Lowell is buried. If you haven't been to Lowell Observatory, he's entombed about 100 feet from the 24-inch refractor in this mausoleum. So he passed away, and thus went the search for Pluto. At this point, William Pickering at Harvard was still searching off and on, not really finding anything. There are a couple other astronomers who searched off and on, but this was kind of the end of this search for Planet X for about a decade. And then in the late 1920s, the observatory had new leadership, had survived going through some lean times after Percival Lowell died. There wasn't any money coming in because Percival Lowell supplied everything financially himself. And so Percival's brother, Abbott Lawrence Lowell, was president of Harvard at the time. And the observatory leadership said, you know, Uncle Percy, as they called him at the observatory, he was onto something. We think there's a planet out there. Will you donate money to build a new telescope to search for it? And he did. And they built this 13-inch instrument that would be used for the search. This is an astrograph, so it's designed for taking wide-angle pictures of the sky. And so through the years that Lowell had been searching, he never really had the ideal instrument for capturing images of the sky for doing wide-angle surveys. But this was a telescope designed specifically for that. So it's a 13-inch telescope right here, then a secondary telescope. And on both instruments, you would use photographic plates. The main 13 inches, the 14 by 17-inch plates, they would capture, and they would do backup plates with the other one. If they found a planet suspect, you could look on the other plates to confirm it. So they got money to build the telescope, and they had a new facility up at the observatory to house it, but they didn't have anybody to do the work because there are only 3 astronomers, and they were all tied up with other work. So the problem was, okay, we've got the instrument. How are we gonna search for it? So the director of the observatory, Vesto Slifer, started talking to colleagues around the country, wondering if anybody has an assistant or maybe even some money to support an assistant to come to Flagstaff and carry out the search. Well, they would take plates in the sky, photograph the sky at night, then during the daytime, analyze these plates. And so this was Slifer's dilemma. Enter the picture, this guy, 23-year-old at the time, Clyde Tombaugh. And Clyde Tombaugh he was born in Illinois, but grew up in Burdett, Kansas, about an hour north of Dodge City, in fields, wheat fields. And what do you do at night in Kansas? He fell in love with astronomy. There's not much else to do in Kansas at night, and the skies were really dark. And so Tombaugh, I think, as another example of that human persistence and drive that's part of the Pluto story, he didn't have any money. The family they were poor dirt farmers. And so he built his own telescopes. He had to raise money to get the glass for the lens that he ground himself. But otherwise, he built the telescopes out of whatever he could find. And this is the third one he built. This is a 9-inch telescope. And it's a fascinating one because it's all built out of farm parts. Like the base is from a cream separator. There's an axle from a Buick over here, some gears from farm machinery. This is from a grain elevator. He didn't have the money, but he had the inspiration. And he didn't take no for an answer. And I think that's the story with Pluto that repeats over and over again, from early searches to New Horizons and beyond. People who said no, but there are others who said, yes, we're not going to take no for an answer. That was Clyde Tombaugh. He was very driven. He made some drawings with that 9-inch telescope. These are a couple he made in 1927. And he got to the point where he started thinking, he's 23 years old. He doesn't want to be a farmer because it's so weather dependent. And he saw how his family suffered through limited funding. And so he decided to send his drawings off to different observatories just to see what they thought about his work. And one of the places he sent them was Lowell Observatory, because it was known as a planetary research center. So he sent these drawings off, and this is just that time when Vestas Life, the director, was trying to figure out who is going to help with this project. It was an interesting element of timing. Had Tombaugh sent that note 6 months earlier or later, he probably never would have been hired at the observatory, but the timing was just right. And so he sent these drawings off and got a letter back with questions like, what kind of physical condition are you in? Are you used to staying up late at night and things like this? And it soon led to him getting a job. They offered him a position at Lowell to help with the search. And so at nighttime, he would be on dark nights, he would be creating these photographic plates. And then in the daytime, he would analyze them on this blink comparator machine. And that was his life. Well, as this was happening, so he was hired in 1928, and within a few months, within a year, he would make history. But after he was there a few months, a visiting astronomer told him, "Young man, I'm afraid you're wasting your time. If there are any planets, they would have been found long before this." And Clyde Tombaugh did not take that seriously. It probably inspired him, in fact, to continue his search. And lo and behold, within a few months, looking at these plates taken in January of 1930, he made a discovery of what we know today as Pluto. And today's standards of looking for planets is a little bit different, but this was Clyde's. This is a close-up of each of those plates, and the arrow, not there at his time. You can see little Pluto over here, that little dot right there, but it's not right there. I mean, imagine the focus and attention to detail required to pick that out. He was the right person for the job. They had the right instrument for the job, and they believed in this project. And belief in the project is what really drove it. So he made this discovery on February 18th, 1930, and this really inspired a lot of people. I wanted to show this slide. Let me go back for a second. So he's searching for this by parallax, looking for how something a lot closer to us like a planet changed its position compared to the distant background stars. And so years later, with his students, they recreated, and this is searching for Clyde Tombaugh, with here's Clyde here, and then he's jumped over there with the arrow pointing to the astronomer. So this is a kind of a classic picture of Clyde Tombaugh. So after the discovery, this made news worldwide. It put Flagstaff on the map. It also was a great boost for astronomy. This is 1930, the depths of the Great Depression. Front page news was not positive, but this made, above the fold headlines right here. Reminiscent of 85 years later, as we saw, I think Ellen showed last night, of New Horizons, above the fold news. And I have to point out, in deference to my colleague Will Grundy, that there's in this front page from New Horizons, there's quotes by Alan here and Will and Kathy Olkin. If we go back here, let's see here. Yeah, right here. Here's Grundy in the headline right here. I'm pretty sure it's a different Grundy, but you'll have to talk to Will about that. So this made news worldwide and inspired so many people, both scientists and non-scientists. I wouldn't say especially in Arizona, but Arizona certainly continues to carry the torch for Pluto. And that inspiration continues today. As a side note, this is one of the state representatives in Arizona, Justin Wilmoth. And after a visit to the observatory and learning about Pluto and its unlikely discovery and the sort of drama surrounding it, as he said, and the pride that he and other Arizonans have with it, he introduced a bill a couple of years ago to name Pluto the official state planet of Arizona. Like there's the official flower and the official mineral, and it passed after some spirited and fun discussion on both sides. And so it became the state planet. There are other states that have recognized Pluto as a planet, but this is the only state with the official state planet. So I think the next goal now is to change the Arizona flag that has a star in the middle to make it this. So that'll be the next goal, I think. So back to Pluto's discovery. After it was discovered, the general public wanted to know, what do we call it? And it was a few months before the name Pluto was officially suggested. And in fact, the observatory, after Pluto's announcement and made headlines, they got telegrams and letters from around the world, and there's still about 300 of those in the archives. Several people suggested Pluto, but the first one they received was from an 11-year-old girl named Venetia Burney. And you know the name Burney is featured on Pluto now. So she was the first one to suggest that name. Another one was, what's the orbit? That was something that scientists wanted to establish. And over the ensuing months, and especially by finding Pluto on old photographic plates like those from 1915, they were able to establish this orbit. And then the other thing is, gosh, if there's this thing out there this far away, are there other things like it? And thus began this question of, is there, if there's one, is there many? Is there some sort of zone out there, some sort of belt of other objects out there? So not too long after the discovery, later that year, there is an astronomer at UCLA named Frederick Leonard. And who's heard of Frederick Leonard? Oh, I see one lone hand back there. Frederick Leonard's name is not usually mentioned in books about Pluto, but he played a key role in hindsight. And you can see why you might not have heard of him. He wrote this paper in Astronomical Society of the Pacific leaflet, not a major publication. And he was writing about Pluto and thinking about it. This is August 1930. And this is kind of long, but I want to read it. He said, is there any reason to suppose that there are not other, probably similarly constituted members revolving around the sun outside of the orbit of Neptune? Indeed, it may ultimately be found that the solar system consists of a number of zones or families of planets, one within the other. As a matter of fact, astronomers have recognized for more than a century that this system is composed successfully of the planets of the terrestrial planets, the minor planets, and the giant planets. Is it not likely that in Pluto there has come to light the first of a series of ultra-Neptunian bodies, the remaining members of which still await discovery, but which are destined eventually to be detected? He got it. But a little-known publication, it was a few years later, in 1943, that a more well-known person, I say astronomer, but he wasn't really a full-time astronomer. He was a soldier. He was a businessman. One of his relatives was into astronomy, so he kind of picked it up as a hobby. And he wrote an article in an astronomical journal, again, not a very well-known one. And in it, he talked about a planetary system, the solar system. And in this first paper, he said, it may be inferred that the outer region of the solar system beyond the orbits of planets is occupied by a very large number of comparatively small bodies. So if we go back to Leonard, in this room, one person has heard of him. Who's heard of Edgeworth? So there's more that have heard of Edgeworth. Who's heard of Kuiper? Everybody's heard of Kuiper. So as we get further on, the next person we talk about is Kuiper. In 1951, he published his thoughts about the solar system and pretty enigmatically talked about there might being a zone of bodies out there, but then suggested, because of what they believed Pluto's mass was at the time, it's probably cleared out. Pluto's mass probably cleared it all out. So, but it was called the Kuiper Belt, perhaps not accurately, depending on how you look at history. It was earlier on that people suggested it, but Kuiper was connected to it in a later paper that used the name Kuiper and a belt of objects, and soon it was known as the Kuiper Belt. That was Julian Fernandez years later. So the name Kuiper Belt is sort of an interesting, enigmatic thing. But starting after the discovery, the upshot is that scientists thought maybe there's others like it out there. And it was theoretical for a while, then astronomers started searching for it. But the search didn't get very far because, as we know today, we didn't have the technology. We were using the old photographic system, using a blink comparator. We didn't have good enough technology to do it. Well, let's jump ahead a little time to 1969, one of those watershed moments in certainly human history, but certainly space history. Not too long after Neil Armstrong, Michael Collins, and Buzz Aldrin flew to the moon, and humans first stepped foot on another planet. Not too long after that, we had another revolutionary thing for astronomy. Later in that year, William Boyle and George Smith, they were looking for a way of increasing memory, and they came up with what we know today as charge coupled devices, CCDs. And this, while it took a few years to develop these, this was certainly a watershed for astronomy because it ultimately would allow for, among other things, searching for really faint bodies in the outer solar system. So this is 1969 when they first developed those. In 1976, Brad Smith and Jim Janicek first applied CCDs to astronomy. Using a telescope in southern Arizona, they took the first CCD image, astronomical image, and here it is, Uranus. We've come away since then, but this was the first one. And so it still took a while to get it embedded in astronomy. There's still development. There's still the old-fashioned way of doing astronomy, of taking pictures with analog and analyzing them. One great example is the year after they got this image. Many of you saw Jim Christie last night. Jim Christie was working at the Naval Observatory here in Flagstaff and was looking to, he studied double planets, but he was also studying Pluto and wanted to refine its orbit and its position. And so we asked some scientists at the Flagstaff station of the Naval Observatory to capture some pictures. And these are a couple of pictures they captured. And you can see here, and then this one is a little bit funky on the side. And some of the scientists look at this and discard the pictures. They said the pictures were defective because they had that irregular thing there. Well, Jim Christie looked at it and said, I think there's a reason for that. Captured some more pictures and realized that that little knob on the side changed position at a regular rate. And he realized that he had a satellite. That, again, for those of you who were there last night, met Charlene. And I show this picture just because they were there last night. This is a photo taken a few years ago. After Jim discovered this moon, he wanted to figure out what to call it. He at first thought about like Oz and somewhat like Wizard of Oz and some other things. And then he thought, he had been married to Charlene just a couple of years. He said, why don't I name it Charlene? And here's his dictionary. He still has this. He was looking up, he thought maybe Charon, like part of it Charlene and then on like a proton. He combined those words. Well, he looks up this word in the dictionary and realizes that's actually a mythological character and would fit. And so named the moon after Charlene. So in deference to her, there's about 17 ways of pronouncing Charon. I go with Charon in honor of Char, because she was inspiration behind what Jim did. So we're moving on with CCD technology. It's getting established, but we're still doing things the old-fashioned way. We'll jump ahead again to another watershed year in astronomy, 1988. As Alan mentioned last night, when we started having discussions about sending a spacecraft out to Pluto. And also that's the year that Pluto's atmosphere, as we'll talk about a little bit later this morning, Pluto's atmosphere was confirmed based on both ground-based occultation observations in Australia and elsewhere, as well as observations aboard the Kuiper Airborne Observatory with Jim Elliott and others. They confirmed Pluto has this atmosphere. At the same time, Dave Jewett and Jane Liu started searching using this this better CCD technology, start searching the outer solar system for any bodies that might be out there. And they started doing this 1987, 1988. They ended up in Hawaii searching for this. And in 1992, they discovered what they first called Smiley, after a character in a John le Carre novel that she happened to be reading at the time. It was tentatively called 1992 QB1, and now is 15760 Albion. The first, well, we consider today the first of the Kuiper Belt objects discovered after Pluto and Charon. So with this discovery, much like the discovery of asteroids in 1801, after they found one, they found another and another, and then soon they found a bunch. And the same thing happened with Kuiper Belt objects. After the discovery of this first one, they found a bunch more and continue to find a bunch more, and confirming what starting right after the discovery, some of those scientists thought there is this third zone out there of bodies that we call the Kuiper Belt, or the Kuiper Edgeworth Belt, or whatever the name might evolve into over the years. So that's I don't know if you consider that brief or not, but a brief introduction to how we got here today. What led to, why are we studying Pluto today? There is early vision that there's a planet out there. And as we know today, Pluto's idea, his planet X is not Pluto. He was looking for a really large body whose gravity could pull on Uranus and Neptune. Pluto's size could not do that. So Percival Lowell was really looking for a phantom, but because of the dedication and hard work, if you systematically search the sky, you find stuff, just like William Herschel did in 1781. And so I think it's a fascinating story. And again, listening to Ellen last night, talking about the challenges of New Horizons and how far we've come in Pluto, from an idea out there to, oh my gosh, look at that dot, look at the world. And then moving on to the Hubble imagery and Mark Bowie's initial maps and team's initial maps, and then what New Horizons revealed. Pluto is this story of perseverance, of not taking no for an answer, of saying, yes, I can. I think I think that's why it resonates with so many people outside of the science community, because they recognize what it takes, what it has taken to find Pluto, to understand Pluto, to study it. And I think that's one of the reasons that inspires so many people today about Pluto. And I can speak directly on that as somebody who is at Lowell Observatory, and every day people are coming in and wanting to know what's the latest about Pluto. And the work that you all are doing are inspiring people, whether you know it or not. Every day they come in and want to learn about it. So I thank you for all the work you're doing and the inspiration. And thanks for letting me talk about this a little bit today. So with that, we have a few minutes for questions or statements, if anybody has any.
Kevin, thank you for a wonderful kickoff to today's meeting. I know that when Pluto was discovered in 1930, pretty shortly, archival images of Pluto turned up, going all the way back, I believe, to about 1900, which really allowed the orbit to be improved quite a bit almost immediately. And I do remember that Milt Humison, who was working, I think, for Shapley, and who was conducting a search for Planet X, actually had made images of Pluto in that search, but not spotted it way back in 1919. My question for you is, did any of the Lowell attempts to find Planet X before Tombaugh see Pluto?
Right, yes. So, and yes. So in 1915, one of the scientists working with Lowell, Thomas Gill, had used a 9-inch telescope, and he captured it a couple times in 1915. Like you said, that helped them establish it earlier. I think in this case, I mean, certainly astronomers might have kicked themselves for not seeing it earlier, but it wasn't obvious. I mean, these were enigmatic small dots in a field of maybe 200,000 other dots. And the early plates at the observatory weren't as good as the one I showed. They were pretty rough. And so it's not surprising if they missed it, but that was critical to figuring out the orbit. There's a story about one astronomer, I think he was maybe at Harvard, because the observatory didn't release its initial orbit for a while. And astronomers wanted to know the orbit, and they wanted to know the position so they could figure the orbit. And the observatory was pretty quiet about it initially because they wanted to release it. And one student was at the movies, and at those times they would have like the movie tone where they would play news of the day. And there was a picture of Pluto and a picture of the sky map that the observatory hadn't shared. And the student made notes and went to a star map and figured out where the position was. And that's how it started leaking out. And eventually the observatory did release the positions.
Thank you.
I really appreciated the history you brought together, and particularly the run-up to, Jewett's discovery of, which of course opened everything up. So I have a question, and it may be that everybody in the room knows the answer to this already, but is there, or have you put together perhaps some, proper study of how, not study, but, how we went from Pluto to the Kuiper belt? So you have, Leonard and you have Edgeworth, but I don't know is how seriously people thought about these things, thought about Pluto's orbit, tried to understand it, prior to, the current picture we had. So it's several decades of wondering, what Pluto was, why is it in this funky orbit, and so on and so forth. So I guess my question is there a good history of that intervening time, how we got to Kuiper?
I mean, it's certainly been written up in several books. Bill Sheehan and Dale Cruikshank cover it in their recent Pluto book. I think, Alan, you've covered it in one of your Pluto books with Jacqueline Mitten from 1990s, I think that was 96. So it has been covered, but I think looking, it could be covered more because of the Edgeworth and earlier suggestions. Those were just suggestions. I mean, they mentioned it, and I think that first graphic I showed where, that guy, he just nailed it. But how many other scientists were looking for it? Like a couple of the scientists, Kuiper was the first mainstream astronomer to comment on it, and his comments were really vague and kind of off center, I guess you could say. And so I think it took years before it was, seriously considered.
Yeah, I guess the related question was, so, Kuiper said this, and then, was just something, oh yeah, Kuiper said that once, or was there somebody said, oh yeah, maybe this is something, we're thinking about?
Well, yeah, it still was years before anybody seriously looked for it. And of course, his name was associated with it just because he was Kuiper. And that paper years later that mentioned Kuiper. And that was back in the days when, a leaflet of the Astronomical Society of the Pacific, if you didn't subscribe to that, it wasn't in the literature. Who knew about it? Today, we have much more knowledge of all of the literature out there. But back then, they just, it's been conjectured, did Kuiper know about like Edgeworth's paper or not? Some say maybe he did and he chose to overlook it. Others say he probably didn't know about it. So, Kuiper's name really got a lot of attention, but it still was years before they really started thinking about it seriously.
Thanks, Kevin. I was thinking about what we knew about Pluto and when. We knew its orbit early on, almost immediately, and you probably have some thoughts on when we knew its rotational light curve, which has huge amplitude, 30% amplitude. It's interesting in the Leonard excerpt you showed, he writes, we know its mass. Well, we don't know its mass. We didn't really until Pilcher, Morrison, and Cruikshank's paper in 1976 with 4 filters. They write about discovery of methane on Pluto and it has to be small and bright. How they figured out it was methane with 4 filters is another story, and how Dale knows the answer ahead of time somehow. But to me, that was the next big step forward,
Yeah.
figuring out this is a really bright, cold, small place.
And I've wondered also, like that Leonard, especially also Edgeworth, they're assuming Pluto to be a lot larger. And so if they knew the actual size, would they have still predicted that there was a zone out there or not? I don't know. Yep.
Yeah, so sort of in a way, Cap, coming back to Todd's question, part of the reason the obscure bits of astronomical errata didn't propagate is that there was a competing narrative. So when Pluto was discovered, the very well-known astronomer in England, R.A. Littleton, imagined a new origin story. And because of the similarity between the absolute magnitude of Triton and Pluto and their rotation rates, the periodicity of Pluto's brightness, that in fact Pluto and Triton were original moons of Neptune, had a gravitational interaction. Triton is sent backwards and Pluto is kicked out. So there is no third zone. There's no other bodies. Pluto's just an escaped satellite. And that's what was in books that I read when I was a boy. So you would not ever hear about Edgeworth in any kind of popular literature.
I hate to say that you're dating yourself.
Well, I am dating myself.
Yeah. Right. Well, I think we're about at one more question. Yep.
I just also wanted to weigh in on this debate, and it was a little before my time, but as I understand it, the discovery of 2060 Chiron and the Centaur population is what led us to realize there was a large population of bodies. So that was 1977 or so. So in the 70s, 80s, and Julio Fernandez started to understand there was a belt out there.
Right. Yeah. Yeah. It was really getting into the 1970s and 80s and beyond, when there was, instead of just conjectures, it was seriously looking and thinking there was something there.
Fascinating.
Okay. Thanks very much.